guys, welcome to another lecture from Introductory Statistics. In the previous lecture, as you observed, we have already started the concept of random variables and we built it up. This lecture, let's try to understand different type of random variables. Let me give you an example. Suppose you want to pursue a certain course at some university and you want to give them a call to figure out something. So you will ring them up for some technical support or something. You will ring them up. Once you ring them up, maybe someone picks up the call and is able to help you out, or maybe your call goes unanswered, right? Let's say that when you are able to speak to someone immediately and you're getting help, that is a success. And when that's not happening, that's a failure. Let's represent this in terms of random variable. What we can do is we can take x as our random variable. X is a random variable which can represent success or failure. Now remember, random variables are to be represented with numbers, right? I can represent it with numbers. So what I can do is when I'm getting a success, that is somebody is immediately answering me, that's a success. Let's give it number 1. And when nobody is answering and I'm not getting any help, let's give it number 0. So what we can do is we can represent this scenario as an experiment with our sample space being success, failure, because that's the only possibility, right? Either you will have success or failure. So when your random variable is a success, the value of the random variable is 1. When the random variable x is a failure, the value of this random variable is 0. This is how you can actually make use of random variable to understand any given scenario. The random variable x here indicates either 1 or the number 0. The student can immediately speak to someone. In terms of the kind of representation that we learned in the previous lecture, your sample space consists of success, failure. Okay, so this point is success, this point is failure. Success is being represented by 1 and failure is being represented by 0. And that's what is your random variable. Okay, let's consider an experiment where telephone number in a certain area code is dialed using number dialer. Okay, randomly you're dialing numbers in a certain area. Let's define y as a random variable and let's give value to y. If it's a success, we will say success is when y takes 1 if the selected number is unlisted in the telephone directory. It takes 0 if the selected number is listed in the telephone directory. Suppose if a number say 528901, this appears in the directory. So according to this random variable, this number is in the directory. So y of this number will take the value 0 because 0 is when it is, the selected number is listed. And just like that, for example, if you take number 528960, 0 and this number does not appear in the directory, then it will take the value 1. The moment it is taking the value 1, you know that this is not in the directory. The moment it is taking 0, you know that it is in the directory. Now understand with these two examples that what has just happened here. In both these examples, a very typical thing is happening. Your experiments are such that either a success will happen or a failure will happen. That means when you will denote your random variable, for example, in the first case, we denoted the random variable as the success. Okay, success was somebody immediately answering your call. In the other one, success was when the number is not in the directory. Whatsoever your random variable is taking only two values, 0 and 1. howsoever you define your success and failure. The only possibility for the random variable is to take two values, 0, 1. Now, such a random variable has a special name to it, and that is Bernoulli random variable. A Bernoulli random variable is a random variable whose only possible values are 0 and 1. This is one very important type of random variable, so always please keep this in your mind. Another example I want to give you guys. Now, there are different kind of experiments that you can, think of. Okay. Let me now take up an example where you will have some other kind of scenario. It's not necessary that every time in our experiment, there are only two possible things. Okay. It's not necessary that the random variable will always just take 0, 1. There could be different scenarios. Let's take another example. Consider an experiment in which 9-volt batteries are tested until one with acceptable voltage is obtained. Now, until one with acceptable voltage. Getting the acceptable voltage is your success. Now, this can happen in what ways? It is possible that the first battery I check gives me acceptable voltage. It is possible that the first one is not giving me the acceptable voltage, but the second one is. Possible that the first two are not, the third one is, and so on and so forth. So in this scenario, my sample space consists of the following: success, failure, success, failure, failure, success, and so on and so forth. I denote my random variable here as the number of batteries tested before the experiment terminates. Then that means X can take what values? X, which is success, will take 1 value. X with failure success will take value 2. X with failure success will take value 3. So on and so forth. X with, say, failure success will take value 7. X with, say, failure, then success will take 9, and so on and so forth. Because you never know. It doesn't, this experiment doesn't tell you that where you have to stop. So this time, the set of random variable, the values that the random variable is taking is not restricted to just 0, 1. In fact, it's not restricted at all. The set of values that this random variable is taking would be infinite, countably infinite, so to say. The random variable can take any possible positive integer. Therefore, it's an infinite set. So yes, your random variable can take infinitely many values. So this is another type of random variable. Now, is it necessary that the random variable takes only natural numbers? Let's see through an example. Suppose that in some random way, a location means latitude and longitude, in Indian subcontinent is selected, and we define a random variable y, and we define y as the height above the sea level. So in this example, y for the highest point is Kanchenjunga. So the latitude, longitude is 27 degree, 42 minutes, 9 second north, and 88 degree, 8 minutes, 48 second east. And the value of this random variable would be 28,169 feet. The lowest point is Kuttanad in Kerala, and the latitude longitude is 9 degree 25 minutes 30 second north, 76 degree 27 minute 50 second east, and minus 8.9 is 9 feet is the height above the sea level at this particular point. But tell me something. Now, between these latitude, longitude, how many points do you think you can generate? Many points. Can you actually say from here to here, Will you be able to count all these points? No, you won't be. So what you can say is that the height of all other points that will come will be between these two, but you can't point out discretely what exact height it would be. It can take all the values between these two continuously. So therefore, what are the type of random variables? There are two types of random variables. You can have random variables from certain experiments, which could be taking value discretely, discrete values. Now, what do you mean by discrete values? Discrete values like, it's taking 0, 1, 2, so on and so forth. It can take negative also, but numbers. It's a finite set of numbers that what the random variable is taking. Or if it is infinite set of numbers, it is countably infinite. You are able to count. Or else the random variables, like in the previous example, could also be of continuous nature. It can take values continuously between certain intervals, like the way in terms of height above the sea level, it can take continuously. Different location points will have continuously, you can generate different values. Okay. So a discrete random variable is basically a random variable whose possible values constitute either a finite set of values or else can be listed in an infinite sequence in which you have first element, second element, third element, so on and so forth. This is what is countably infinite, what I've mentioned here. When you can count, even if there is infinite number of entries, but you can count first element, second element, third element, so on and so forth, like in the case of natural numbers. For any random variable to be called continuous, the following two properties should be satisfied. What are these? Number one, its set of possible values are either all the numbers consist in an interval. Okay, like for example, from minus infinity to infinity, or everything on the number line. Okay, or say from some value a to b, all values between a b. It could be closed interval, open interval. Or else, if not just an interval, maybe it's a union of, say, from 0 to 1, union of disjoint intervals, say 2 to 3, union 4 to infinity, this kind of disjoint union. All the points. So in this case, as you saw in that example also, you can't really pinpoint values in between. The values are continuously coming in. Okay. The second point that it also satisfies, no particular value can have a positive probability. No particular value of the random variable can have positive probability. That is, probability x equals to one particular value c is 0. That is a point probability when it comes to continuous random variable. Probability of a particular point is always 0. These two properties should be satisfied for it to be a continuous random variable. Crux of the story, there are two types of random variables, discrete and continuous. You can also have mixed random variable, but exclusively if we are talking about discrete and continuous. When do you create random variables? When you're trying to find out something, okay? Using certain experiment, within certain experiment, when you are trying to find out something, that's when you create random variable. So under certain experiments, like for example, height is something which is associated to continuity. Similarly, if you would be creating a random variable which is time based, which is based on time, then again, time is a continuous entity. Time changes continuously, right? You will not be able to pinpoint time. So that also would be continuous. In the further lectures, we will understand in detail many more types of discrete and continuous random variables. For today, it was Bernoulli. Then we understood with certain examples, discrete, what kind of random variables are discrete, and also what kind of random variables would be called continuous. Thank you very much.